Now dear students, now we are starting class 9th, first chapter, number system. Number system. So, in number system, first and foremost, you are going to study about various numbers available in mathematics. Okay? So, now, various number sets available in mathematics. First, we will begin our discussion with set of natural numbers. So you know, set of natural numbers is denoted by n and it is equal to 1, 2, 3, 4, so on and so on. So on and so on. Natural numbers are also called as countable numbers, which we use to count some objects. Now, the second set is set of whole numbers. It is denoted by W, which is equal 0, 1, 2, 3, 4, so on. Next, third set of integers. Z is equal 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. Next, coming to rational numbers. Rational numbers, it is denoted by Q. It is a set of all x such that x is in the form of p by q, where p, q are integers. P, q are taken from set of integers and q is not equal to 0. So rational numbers are in the form of p by q, where p and q are integers, q is not equal to 0. So any number that can be put in the form of p by q, where p, q are integers, q is not equal to 0, is known as a rational number. If you take some examples, 2 by 3, 5 by 4, minus 7 by 2, 8 by 7, etc., etc., etc. So these all are rational numbers. Now coming to irrational numbers, this q dash. Q dash is equal to a set of all x belongs to R such that x does not belong to Q. Means in the set of real numbers, the numbers which are not rational numbers are called irrational numbers. The set of irrational numbers is represented by Q dash. Q dash is equal set of all real numbers such that that real number is not a rational number. So, in other words, in a simple language, if you want to say, A real number which is not a rational number is known as irrational number. In other words, if you want to say a real number that cannot be put in the form of p by q is known as irrational number. Are you following? Once again I will repeat. You see, a real number which is not a rational number is known as irrational number. Or in other words, a real number which cannot be expressed in the form of p by q is known as irrational number. Understood? So now we have law of density of rational numbers. Law of density of rational numbers. It is most important, that is, I will read out. You see, between any two rational numbers there exist infinite rational numbers. Between any two rational numbers there exist infinite rational numbers. Understood? So this is called law of density. So between any two rational numbers there exist infinite rational numbers. Right? In other words, saying if x and y are any two rational numbers such that x is less than y, then x plus y by 2 is a rational number such that x is less than x plus y by 2 is less than y. So between any two rational numbers x and y, where x is smaller comparing to y, there exists a rational number x plus y by 2, so that x is less than x plus y by 2 is less than y. See, this you can use to insert a rational number between any two given rational numbers. Insert or find a rational number between 1 by 2 and 3 by 4. 1 by 2 is smaller than 3 by 4, right? So let us consider x is equal 1 by 2 and y is equal 3 by 4, where here x is less than y. Now a rational number between x and y equal to x plus y by 2 is equal to x is 1 by 2 plus y is 3 by 4 by 2. So if you take 1 by 2 outside and take 4 LCM, then you get 2 2s are 4 plus 3. So equal to 1 by 2 into 5 by 4, which is equal to 5 by 8. So 5 by 8 is a rational number that is lying between 1 by 2 and 3 by 4. Okay, so 5 by 8 is the required answer. Understood? So now for one rational number, this method would be sufficient. But suppose if you want to insert n number of rational numbers between two given rational numbers, then this method also you can follow, but it is a little time consuming. So I am telling one important note. You please note down this. If x and y are, it's a not two rational numbers, such that x is less than y. Okay. To insert n rational numbers between x and y, are you following? To insert n rational numbers between x and y, take some d is equal y minus x by n plus 1. It is a formula. Remember that, don't think more than required. I am giving a simple method. Okay. So take d is equal y minus x by n plus 1, and the first rational number between x and y, say a1, second rational number a2, third rational number a3, and so on. We are inserting n rational numbers. So an is the nth rational number. So this starting point is x. Okay. This ending point is y. Now between x and y, these are the rational numbers. Okay. So now how to get this a1 is you take x plus d. How to get this a2 is, okay, you take x plus 2d. a3 is x plus 3d. So on, an is x plus nd. Are you following? So where d is equal y minus x by n plus 1. Understood? See here there is a rational number x. Once again I will repeat this concept. You see, there is a rational number x, another rational number y, so that x is less than y, and you need to insert n rational number, n for 10, 5, 4, like that. Yeah, you need to insert n rational numbers between x and y. Then you have to take d is equal y minus x by n plus 1, and this starting rational number is x, ending rational number is y. Just here I am making you note, here x is first and y is last, and between x and y you have the rational numbers a1, a2, a3, so on, an. So how to get a1? It is x plus d, a2 x plus 2d, a3 x plus 3d, so an is x plus nd, where d is equal y minus x by n plus 1. See, it doesn't mean that this is the only procedure that you have to follow to find n rational numbers between any two given rational numbers. See, there are various methods. Okay, So you can adopt any method. See this this is the only one of the methods I am saying. It doesn't mean it is the only method. Please try to understand. So now let us take an example so that you will understand very well. Insert 5 rational numbers between 2/3 and 5/3. Okay. Insert 5 rational numbers between 2/3 and 5/3, and just I took a small example, okay, to make you understand this concept. See here, 2/3 is lesser than 5/3 obviously, so take x as 2/3 and y as 5/3. See here clearly x is less than y. And number of rational numbers that we have to insert, number of rational numbers that we have to insert is 5 rational numbers we have to insert. Say it is n. So n is equal to 5. So as just now I discussed, we have to first find d. D is equal y minus x by n plus 1. So which is equal y is 5/3 minus x is 2/3 by n is 5 plus 1. So this is 5/3 minus 2/3 is how much? 3/3, right? 3/3 is 1. So it is 1/6. So d you can take as 1/6. Now x is 2/3, right? So you please take this here. Now after x, the first rational number a1, as I suggested, it is a plus d. So are you following? X plus d. X plus d. So x is 2/3 plus d is 1/6. So now, are you following? So if you take LCM, 6 is LCM, 3 2s are 6, 2 2s are 4 plus 1. So which is equal to 4 plus 1, 5, 5/6. So A1 is 5/6. Now A2, you need to find A2, A3, A4, A5, 5 rational numbers that you have to insert. So A2 is x plus 2d, as I said. Okay, so x is 2/3 plus d is 1/6. So 2d means 2 into 1/6, that is 1/3. Are you following? Directly I wrote. So this is 2/3 plus 1/3, 3/3, it is 1. Are you following? So now third rational number, x plus 3d. So 2/3 plus 3 into 1/6. 3 into 1/6 is 1/2. So if you take LCM 6, 3 2s are 6, 2 2s are 4 plus 2 3, so it is 7/6. So now A4, so x plus 4d. So 2/3 plus 4 into 1/6. 4 into 1/6 means 2 2s are 4, 2 3s are 6, 2/3. Are you following? 4 into 1/6. 2 2s are 4, 2 3s are 6, 2/3. So 2/3 plus 2/3, it is 4/3. And at last A5. So x plus 5d. So x is 2/3 plus 5 into d is 5/6. 5 into d, d is 1/6. 5 into 1/6, 5/6. Now if you go for LCM 6, 3 2s are 6, 2 2s are 4 plus 5, which is 9/6. Okay, 9 by 6 means 3 3s are 9, 3 2s are 6, 3 by 2. Did you understand? Now, therefore, the 5 rational numbers between 2 by 3 and 5 by 3 is or 2 by 3 and 5 by 3 or come on, what are the 5 raised number? You see A1, what did you get? 5 by 6. Next 1, next what did you get? 7 by 6. Next what did you get? 4 by 3. Next what did you get? 3 by 2. So these are the required 5 rational numbers between 2 by 3 and 5 by 3. And it doesn't mean that every student should have to insert the same rational numbers between the given rational number. If you change the procedure, between any two rational numbers there exist infinite rational numbers. So this representation is not unique. So you may pick up some other 5 rational numbers. Some other student may pick up some other 5 rational numbers. So it depends on the procedure, which procedure he is taking. So it doesn't mean you got some 5 rational numbers, some other student got some other 5 rational numbers between the given 2 rational numbers. Means it doesn't mean that your answer went wrong. See, this representation is not unique. Please do understand this point. Okay, you got these 5 rational numbers between the given 2 rational numbers because you have adopted a specific procedure. If that another student is going in some other procedure, he may be getting some other 5 rational numbers between the same 2 given rational numbers. Like that the numbers which are inserting between it is strictly okay, it is personal, so it differs from student to student. Now students, our next point of discussion is decimal expansion of a rational number. So let us see how the decimal expansion of a rational number will be, taking 2 to 3 examples. First example I am taking as 5 by 4. So now let us go for division. 5 by 4, 4 ones are 4, 5 minus 4 1, 0.0, right? 4 twos are 8, 2 0, 4 5s are 20, 0. Therefore 5 by 4 is equal to 1.25. So the decimal expansion of 5 by 4 is equal to 1.25. So it is clearly a terminating decimal. So it is clearly a terminating decimal. A rational number is said to be terminating decimal if the division process ends after some stage. Okay, the division process should end after some stage. So it is a terminating decimal. Now let us go for another example. Say 8 by 3. So now let us divide 8 by 3. So 3 twos are 6. 0.036 are 18. So 2036 are 18. 2036 are 18. So this division process will never end. Okay. So this 8 by 3 is equal to 2.66666, like this it goes on infinitely. So this is 2.6 bar. It is represented as 2.6 bar. So it is a non-terminating recurring decimal. This is said to be non-terminating recurring decimal. Non-terminating recurring decimal. So the decimal expansion of a rational number is always either a terminating decimal or non-terminating recurring decimal. Did you understand? Now how to express decimal expansions in P by Q form? This is our next point of discussion. So expressing a decimal expansion in P by Q form. This is our heading now. Expressing a decimal expansion in P by Q form. See, let us begin our example with a terminating decimal. Suppose you have 3.128. This is a decimal expansion of a rational number, 3.128. We need to express this in P by Q form. So you all know how to express 3128 upon. So this, for this decimal you have to take 1. For 3 digits you have to take 3 zeros. So 3128 by 1000. So if you want, you can see further cancel and you can simplify and you can express this P by Q form in its simplest form. So suppose if you go for cancellation with 2 table, 2 15s are 30, okay, 2 6s are 12, 2 4s are 8. So 1564, okay, divided by 500. So it means you can still cancel with again 2. So 2 7s are 14, 2 8s are 16, 2 2s are 4. So here 250. So again you can cancel with 2. So 2 3s are 6, 2 9s are 2 1s are. So here 125. So this division now you can stop here. So 3.128, the decimal expansion of a rational number in its simplest form, okay, it is 391 by 125. It is expressed in P by Q form, and that P by Q form we are taking in the simplest form as 391 by 125. You can directly cancel with a little larger number also, but I proceeded in this way, okay. So now take another terminating decimal, 5.2. Another terminating decimal I took. So how you have to express this in P by Q form? So take 52 by 10. So if you go for cancellation, okay, 226 are 2 5s are. So 5.2 in P by Q form, it is 52 by 10, and if you express the P by Q in its simplest form, it is 26 by 5, okay. So how to express a terminating decimal in P by Q form, now you have learned. So now how to express a non-terminating recurring decimal in P by Q form, we are going to discuss now. See here, Now non-terminating recurring decimals. Okay, we are expressing in P by Q form. So express, I am taking 3 to 4 examples. Okay, express 0.58 in P by Q form. Express 0.58 bar, because as what I said, we are expressing non-terminating recurring decimals in P by Q form, right? So express 0.58 upon bar, 58 bar in P by Q form. Dear students, are you following now? We are expressing non-terminating recurring decimals in P by Q form. For that, I took first example 0.58 bar. We have to express P by Q form. So here see, first consider this is x is equal to 0.58 bar. Say this is equation 1. So multiply equation 1 on both sides by 100. So before multiplication, you do one thing, you just expand this as 0.58, 58, 58 and so on. So this is 2, equation 2. Both are same, but I removed the bar and I expanded. So now multiply equation 2 both sides by 100. You may ask why with 100 means under the bar sign there are 2 digits. So when under the bar sign there are 2 digits, you have to multiply with 100. Under the bar sign, if there are 3 digits, you have to multiply with 1000, like this. So multiplying equation 2 both sides with 100, you get 100x is equal to 100 into 0.585858 so on. So this implies 100x is equal, when you are multiplying with 100, the 2 digits will come towards left side. So 58.585858 goes on. Now just below this you please take our x expansion. It is 0.585858 and so on. So now subtract, you go for subtraction, 100x minus x, it is 99x is equal, so if you subtract, so here this side all zeros, so 99x is equal 58.000, so 58, so x is equal 58 by 99. So this is how we can express a non-terminating recurring decimal in P by Q form. Okay. So now our another example is express 23.3 bar in P by Q form. So now as this take solution, x is equal 23.3 bar, say it is equation 1. Now you write this in expanded form, 23.333 and so on. So this is equation 2. Now under bar sign we have only 1 digit, so multiply both sides by 10. So multiplying both sides by 10 of the equation 2. So 10, the equation 2 is multiplied by 10, so you get 10x is equal 10 into 23.333 and so on. So this implies 10x is equal, as you are multiplying with 10, 1 digit will jump to left side. So then it will become 233.333 and so on. So now just below 10x you write x is equal, okay, 23.333 and so on. Now you go for subtraction. So you go for subtraction, subtract then 10x minus 1x, it is 9x is equal 0, 0, 0, 0.01, so 2. So 9x is equal 210, then x is equal 210 by 9. If you cancel it, 3 70s are 210, 3 3s are 9. So 70 by 3. So for 23.3 bar, okay, P by Q form is 70 by 3. Did you understand? Our next problem is express 1.283 bar in P by Q form. So solution, let us consider this is x is equal 1.283 bar. In expanded form it is 1.2838383 and so on. So this is 1, so this is 2. So now see, 2 digits are recurring here, and under non-recurring position there is 1 digit, okay. So the number of non-recurring digits is equal to 1, so you multiply both sides with 1. So multiply both sides the equation 2 by 10, because under non-recurring position there is 1 digit, so you have to multiply with 10. So multiply the equation 2 both sides by 10, so you get 10x is equal 10 into 1.2838383 so on. So this implies 10x is equal, as you are multiplying with 10, one digit will come towards left side, so it is equal 12.838383 so on. So this is equation 3. Are you following? Now there are 2 digits under recurring position. There are 2 digits now, so you multiply equation 3 both sides with 100, because there are 2 digits under recurring position. So multiplying equation 3 both sides with 100, then you get 1000x is equal, okay, 100 into 12.838383 so on. Are you following? So this implies 1000x is equal, so now 2 digits jumps, 1283.838383 so on. Now you take this 10x which you got in equation 3, please take here. So 10x is equal 12.838383 so on. Now you go for subtraction. So if you subtract 1000x minus 10x, which is 990x, is equal to, this is 0, this is 0, this is 0, this is 0. So 0 that side. 3 minus 2, 1. 8 minus 1, 7, 12. So this implies x is equal 1271 by 990. So 1.283 bar in its P by Q form is 1271 by 990. I think you understood.